In this video, we'll be looking at the formal definition of limit. We'll start by letting f be a function defined on an open interval containing c, and we'll let L be a real number. So a sketch of this situation would be, this is my function, just any curve. My c is a constant on the x-axis, and my L, which is going to be the limit, is my constant on the y-axis. The formal definition for limit is the limit as x approaches c of f of x is equal to L means for every epsilon greater than 0, there exists a delta greater than 0 such that if 0 is less than the absolute value of x minus c, which is less than delta, then the absolute value of f of x minus L is less than epsilon. Now let me show you that written out in words. So if you want to copy it down, you can. This symbol is the symbol for every. This is the Greek letter epsilon. This is there exists, and this is the Greek letter delta. This symbol stands for such that. And when we talk about distance, when we want to say the distance between x and c is less than delta, that's this expression right here. So the distance between x and c is less than delta. And the distance between f of x and L, that can be shown right here, and that's less than epsilon. So let's come back up to our diagram. And what we're saying with this formal definition is that there's a positive value of delta. And we'll mark delta off. This is our delta neighborhood right around our value of c. So that this value is c plus delta, and this value is c minus delta. And we know then that an independent variable of c minus delta will give us another y value, or a dependent variable, and this value is epsilon. So this one is L minus epsilon, and then up here is L plus epsilon. So this definition, if we say that the limit is equal to L, then basically that's saying that there's going to be a positive delta for every positive epsilon, such that if x is in this delta neighborhood, then f of x will be in this epsilon neighborhood.